Welcome to video 5 about your electric circuits. So if you've been following along with me, you would have seen that we have done 4 videos. Video number 1 was all about setting the stage with the fairies and the pixie dust and the pixie dust tree. And then in that same video, we flipped the fantasy words around and we changed it into not a pixie dust tree, but a battery, not fairies but electrons or charges, and not pixie dust but electrical energy. In video number 2, we looked at what happens when a fairy meets a junction in her path. So what happens to the energy, and we saw that she will use the same amount of energy irrespective of which leg of the junction she will use. In video number 3, we looked at the teams of fairies, because in reality it's not just one electron moving through this electrical circuit. It is a whole team of electrons, so the team of fairies, and we looked at what happens to the team. The whole team will move through obstacles that are in series because they don't have a choice where they want to go, but when they meet a junction they can choose. Some will take the one leg and some will take the other leg, and we know that the easier obstacle will always get the most fairies to go through. Okay, then in the last video, video 4, we did the preparation for the sums, and these are the 4 that we looked at. Now, if you haven't looked at video number 4, I would say it's not a big crisis. I think you will be able to figure out what's going on as we do the actual sums with actual numbers. But if you listen to this video and you feel a little bit lost, it might be a good idea to just at least watch the first 10 minutes of video number 4 so that we are all on the same page. Okay, so these are the 4 that we did the preparation for in the previous video. What we're going to do now is we're going to actually work out the sums. And with this video, you will probably do the same. So you can watch the first example just in slow speed so that you can keep up with me. And then the rest of the video you can watch on double speed because it's just more of the same. And remember, repetition helps. And obviously, you're going to do it on the paper with me. Now, the first one that I didn't do very pretty or neatly because I was just trying to get information across. So you will see that my information lists are incomplete. So I'm quickly going to redraw the circuit and make the information list complete. You can do the same and then just check if you agree with me. Okay, and there is the circuit all redrawn, all with the proper information list, and I also added the numbers that we got from the original question. So if I was doing this electric circuit sum on a piece of paper in front of me, this would probably be more or less how it would look for me, although I would probably put my paper in portrait form. It really doesn't matter, but all the information is here. And even if you just do this, there is enough information on this paper at the moment that I can give you some of your marks. Okay, so that's always good to know. Now, there is one more equation that I need to give you, and that's the one that we're probably going to use the most, and that is V equals I times R. Okay, so the voltage equals the product of the current and the resistance. Now, you might have seen different forms of this. You might have seen one where R is alone, in which case it will be V over I, and we know, if you've done this before, that you can always turn it into a little triangle. Now, you are welcome to do that. I find it is an extra step that is really unnecessary. So what I do is I just work with VIR. And the reason why I work with VIR and why I like it so much is VIR in Afrikaans is vir, so it's an actual word. And you will see it's also the order in which I make my information list. So everything is the same. It's one thing for my brain to remember, and then my brain is happy. Okay, so what we're going to do now is we're basically going to play Sudoku. We are going to look at where is there an information list that is half completed or 2/3 completed so that I can determine the unknown. So you will see that this one doesn't have the highlighted portions yet. I am going to add that. But for now, I want us to look at resistor number 1. So do you see we have 2 of the 3 variables? So what I'm going to do is I'm going to rewrite this VIR formula, VIR, and I'm going to use a subscript 1. So that is for me, so that I know what's going on, and it's also for the person marking my work, so that they know where I got these values from. So from my information list, I'm going to do substitution. My V value is 6. I don't know what I1 is, and then R is 4. Okay, now it's a simple linear equation. I'm going to divide by 4, and I'm going to divide by 4, and then I get I1 equals, and for this you are going to use your calculator, and now you get a value of 1.5 ampere. And there we have one of our values. So I'm going to add 1.5 there. Now, if you did the previous video with me, you would remember that in the main circuit, in the series circuit, all the I values are the same. And because I have this 1.5, I can add the 1.5 there, and I can add the 1.5 there. Okay, does that make sense? Easy, right? Okay. Now, if we just keep on looking at the numbers in front of us, we are looking for an information list that has 2 of the 3 variables. Now, I'm a little bit stuck because here at the battery, I only have one value. Okay, R1 we've done. Here at the P values, the parallel portion, I only have the current at the moment. And with the individual resistors also, I don't have enough information. So what I'm going to do now is I'm coming back to these formulas and I'm just checking, is there something that I can use? Okay, and I'm going to sort of give you a hint. Start with the resistors, start with the bottom of your information list. So if I want to determine the total resistance of the circuit, I need R1 and RP. Okay, so I have R1, that's okay, but I don't have RP yet. If we go to the parallel portion, I have a formula where I can determine my parallel resistance. And it looks like this. So I'm just copying what I've already written. So 1 over RP, I don't have RP. R2A is 8 and R2B is 5. Now, in my calculator, I am going to type it in exactly as it is on the screen right now. So according to my calculator, the answer is 13 over 40. Okay. It's a weird answer, I know, but it's okay. Now this 13 over 40 is the same as 1 over RP, but I don't want to know what 1 over RP is. I want to know what RP is. So I'm going to flip both of the sides of this little equation over. So it becomes RP over 1 equals 40 divided by 13, and then this one is unfortunately a decimal, so we're going to say it's 3,08 ohm. Okay, so RP. So there's a little bit of a mathematical trick that you need to do there, but I think you can manage. And so what I can do now is here at RP, I can include it in my information as 3.08 ohm. Now you will see I am putting some of the units in. It's not really important. I am putting it in so that you can get used to the units, like the ohm and the V and the A. But usually when I do the information list, it's only the numbers because that's what I'm worried about. Okay, so if we continue with this train of thought of looking for an information list where I have 2 of the 3 variables, can you see that I can determine my VP value? And again, we're just going to write the formula. So V equals IR. I write my subscripts, okay, because it makes it easy for my brain now to fit this formula with those information pieces. So IP is 1.5, and this one is 3.08. 3.08 is in my calculator, so I am just going to say times 1.5. And then I get a value of 4.62 if I round to 2 decimals. Okay, and that I can write there. Now remember, when we were using the highlighters earlier, I also said that the voltage in the parallel piece is the same everywhere. So that value equals this value equal that value. So I can add the 4.62 over there, and I can add the 4.62 over there. Okay, and now we're almost done. The only thing that is left is to determine I to A and I to B, and I know that when I add these two numbers together, I should get to an answer of 1.5. So this method also has like a double checking system worked into it. So if you make a mistake somewhere, your sums will tell you, hey, watch out, something's up. Okay, so let's do 2a first. So v equals IR. We have a 2a, a 2a, and a 2a. The v value is 4.62. It's in my calculator. I want to determine, and r is 8. So in my calculator, I am going to say 4.6 whatever is in your calculator, divided by 8. And then I get an answer of 0.58 ampere if I round. And then I'm going to do it again. This time we're working with the 2b values. So it's still 4.62. I don't know. And r is 5. Okay, now I get a value of 0.92 ampere. And if I add these two values together, I do get 1.5. So my double checking system has actually worked, because this equation holds for all the numbers that I have on the paper. And now you are done. Now, I know it seems like a lot of work, and I haven't even told you what exactly the question was that went with this circuit, and it doesn't matter, because usually the order that we just did the questions will probably be the order in which they are going to be asked, because most of the time the way you have the information, it sort of forces you to do the sums in a specific order, because that's just where your information lies. So this is the first one. Let's do the second one. Okay, so this is the second circuit that we looked at, and just to show you, this is the physical question that came from a past paper. Okay, so we have all this information, and then these are the questions, and I'm not going to look at the questions, I'm only looking at the circuit. We've already redrawn the circuit, but we didn't add the information. And it's just copy and pasting. So let's see. From this picture, I can see that the voltage of the battery is 24 volts. So now we're coming back and we're just adding it. So this will be 24. I'm not going to add the units this time. Then we come back. Then we see we have 3 resistors, and they all have a value of 8 ohm. So that one is 8, this one is 8, and this one is 8. And then we can just go back and double check that we have all the information. And it seems like we have everything. So there are ammeters, the current meters. We don't have values for them, and that's also why I took them out. There's a value V2, we don't have a value for that, and then A1. So all the circles you ignore, because those are just meter readers. We are only concerned about the resistors and the battery. All right, and now we do exactly the same thing. So if you feel like you have the hang of this, then you can pause the video and just see where you end up, and then maybe fast forward me, or you can stick around and do it with me. So the first thing that I'm going to do, I'm looking for an information list where I have 2 out of the 3 values. Now, if you look at these information lists, you will see I don't have any of those. So I need to come back to these little equations of mine. And remember, we have one more, V equals IR, that we're going to use. So if I look at the parallel piece, I have the 2 resistors. So that means I can determine RP. So I'm going to do it here. So 1 over RP equals 1 over R2A plus 1 over R2B. So I'm just copying what I did earlier in my preparation. And then I substitute 1 over 8 plus 1 over 8. That's 2 over 8, so it's a quarter. Your calculator will do that for you. But I don't want 1 over RP, I just want RP. So I'm flipping this around. In class, I will show you how to do it with your calculator. So then I get a value of 4 ohm. And that 4 ohm I can come and write here. Okay. So just to show you the marks that you're going to get a mark for your formula. You're going to get a mark for your substitution. And then you will get a mark for the total answer. And to get those marks, you need the number and the unit. Okay, so potentially 4 marks if I give a mark for everything. Now, remember, with the previous example, I told you, even if you just get to this block, I can give you some marks because the formulas are all here. So I can actually give you a mark even though you haven't used it. Okay. All right. So now I still don't have a 3 out of 2 information list, but I can use this little formula to determine RT. Let's do it in pink. So RT equals R1 plus RP. R1 I have, it's 8, and RP I have now, that's 4. So my answer here is 12 ohm, and I can come and write it in there. And everything is complete. I have a formula, I have my substitution, and I have my answer. So all the marks are there. Okay, now finally we can do the 2 out of 3 thing. So let's work with VIR for the battery. So V equals I times R. I'm working with a battery, so it's my total values. VT is 24, I don't know, and R is 12. Now I'm dividing both sides with 12, so I get I equals 2 ampere. And that I can go right there. And because I've used my highlighter, I do not have to remember that I can add the 2A there and the 2A there, because I have this little yellow row that's reminding me, telling me, hey, but those values are all the same. Okay, so we've used that formula as well. Now you will see that we can determine all the rest basically. Let's do R1. I'm going to make that orange. So again, V equals IR. My subscripts are 1, 1, 1. V1 I don't know, I is 2, R is 8, and then I get a value of 16, and the unit here is volts. And I add it over there, 16. Next one up is the parallel piece, VIR, PPP, and then 2 times 4, and then we have a value of 8 volts. And again, because I have used my highlighter, I know I can add the 8 there, and I can also add the 8 over there. Alright, almost done, just the last 2 to go. So this one and this one I'm both going to do in purple. So we have VIR, I have 2A, 2A, and 2A. V I have, that's 8. I want to determine, and R is also 8. 8 divided by 8 is 1, so that's 1 ampere. And I am going to be lazy, and I'm not going to do it again because it's the same. And now see, 1 plus 1 equals 2. And this equation tells me that's exactly what needs to happen. So the parallel current, the current of the total parallel piece of your circuit, needs to be the sum of the individual legs. And we are done. Okay, so this one actually has some physical questions that I just want to show you how you can do all of these calculations on the paper and then just come and add some marking so that I know where to mark. I'm just going to skip question 11.1.1 for now. I will do that in the last video when we put all the theory together. So we're just going to start here at question 1.2. They say the circuit is closed. So for this whole story, the circuit needs to be closed. Calculate the equivalent resistance of the circuit. So equivalent resistance of the circle just means they want the total resistance. Okay, and we actually did that here. This whole piece that we did here, we did to get to the RT value. So this will be question 1. Okay, the next one is calculate the reading on voltmeter V2. So voltmeter V2 is over this 8 ohm resistor, and I know we changed the subscripts a little bit, but you can see it's this value there, okay? And it's our orange little sum. Now to get to the orange, we also had to do the green part. So even if you only draw your little block around the orange part, the green part is still there, because to determine V1, we needed I1, and to get I1, we needed VT, okay? Which sounds very complicated, but you know it's not, because you just did it with me. And then the last one is how do the meters on ammeters A2 and A3 compare with each other? Now we actually went and did a little calculation over there. I didn't do both, but you are going to say that they are the same. And you can go do a little calculation. That's what we did there. So there was 11.4. The other thing that you can also do is you can say because the resistances are the same, the current will also be the same. Okay, so this is our third question. It's the last one I am going to do with you. Number 4 in this little sequence of ours, I am going to leave for you to do as a quiz. Just do one on your own without my help to make sure that you know what's going on. Okay, so this is the last one we're going to do. It's again, the circuit looks the same. I have my VIR information lists, and now I'm going to look for an information list, which I again don't. But I'm not stressing out because I know I have these other formulas that I can also use. And I don't know if you've noticed a pattern, but we tend to start with this one. So again, I have my two parallel resistors, and with those two values I can determine the equivalent resistance of the parallel piece. And for that I am going to write my formula. I am going to show my substitution. Then I'm going to use my calculator to determine the answer. The answer here is 2/3, but remember now, really the only thing that you might forget is it's not 1/RP that we want RP, so we need to flip this answer around, and that becomes 3/2 or 1.5 ohm, and that is a 1.5 over there. Okay, and now I can start playing. So I have a VIR. Let's make this one light blue. V equals I times R. Now I'm using my P values. This one is 4. I don't know what I is, and R is 1.5. And when I ask my calculator what is 4 divided by 1.5, I get an answer of 2.67 ampere if I round to 2 decimals. And there I have a 2.67. Now, I've been a little bit naughty. When I redrew this one, I didn't add my highlighter marks. So I'm going to add them back. Okay, and immediately I can see that that 4 over there, I can also add here. And I can also add there. So I could actually have started with the individual parallel pieces, but it doesn't matter. The sequence and how you solve these, when it comes down to it, is really not that important. The other color that I still need is for my I values. So the 2.67 I can write there, and the 2.67 I can also write there. Okay, where do you want to go next? Let's, just for sanity's sake, let's go determine the current in the parallel legs and just make sure that we do get back to 2.67, because then we'll know that we really are on the right track. So V equals IR. But now I'm working with my 1A values. Don't be lazy and not write the subscripts. I can talk a whole hour about why they are important, even though they seem unimportant, but please just write them. Okay, so now I get A is 2 ampere. Okay, so I feel okay, and then I'm going to do it again for my 1B values. That one's 4, that one we want to know, that one is 6, and then I get an answer of 0.67 ampere with my calculator. So 0.67, what did I write there? So 2 plus 0.67 does give me 2.67. So this formula over there holds. So I know I'm on the right track. So R2 we can also use now because we have 2 out of the 3 variables. Let's make this one pink. I'm working with the values of R2 now. I want to determine V2. I is 2.67 and that one is 4. So now I get 10.67 volts. And we can add that there. Okay, so the last piece of information that we haven't used is the total values. So now there's 2 ways of doing this. Either you can start with V and then figure out R and then double check yourself with R, or start with R and then double check yourself with V. Let me show you what I mean. I am going to start with this equation so that I can get my total resistance. Okay, so RT equals RP plus R2. RP is 1.5, R2 is 4, so I get a value of 5.5 amperes. 5.5, so in my information list I only write 5.5, but in my equation I write the unit so that I am sure I can get all my marks. Okay, so now we're going to do VIR with my totals. V equals I times R, T, T, and T. I is 2.67. Now 2.67, if you've done this with me, you will see that it is actually 2.66666. Please use all the decimals. You can store the answer in your calculator if you know how to do that, or another way is work with about 4 or 5 decimals. then you should be okay with your answers. Okay, so now I get my VT value as 14.67. Again, if I round to 2 decimals. So this is 14.67. And now I can double check myself with this formula. So my total voltage needs to be the sum of the parallel voltage and the voltage over resistor 2, and it does add up. 14.67 equals 4 plus 10.67. Okay. And I know I'm right. And for me, it is actually more important to know that I'm right than to know that I will definitely get all my marks, because all my calculations are on the paper. Okay, so the questions coming from circuits, I know you can't see the questions here and I'm not showing them on purpose, but they will be about 10 marks. And time-wise, that means you have about 12 minutes to solve this whole question if you want to stay inside your time frame. We've been busy now for 10 minutes. The video will probably be shorter because I edit things out. But from start to finish, I've been busy for 10 minutes. That is more than enough time. Now, if I can just remind you what we did with the previous example, the only thing left for me to do is just draw nice borders around my calculations and number them clearly so that the person who marks your work can find what they are looking for. But in terms of formulas, it's already there even before you started. Okay, so there is one more to go. I am not going to do it for you. You are going to do it yourself and then submit it for a mark in the form of a quiz, and I will make sure that you have the link for the quiz. It's either in the description of this video or it will be in a handout that I give to you. Now, when we did the preparation work, we didn't actually add in the values. The values are with the question at the quiz, so you'll actually find them there as well. But just to let you know that the total voltage is 14, and you also have the total current. If you read the question, it's 2 amperes, and we have this little resistor there, it's 6, and this little resistor there is 3, and we have this little one is 4. Okay, and I hope immediately you can see how you're going to tackle these questions even if you don't know what they're actually asking. Okay, good luck. If you are still struggling after this one, please let me know so we can figure out which screws are loose.